No, you can't get
All right.
I didn't go last week.
Let's focus, please. You should all have a booklet, or if you haven't got a booklet, just let me know, or you could download it from Google Classroom.
No, two.
All right.
No, two. I've been to 2 weeks.
Only two, no.
Now,
3 did that. No, I thought 4.
No.
this has come up in the exam before, and you should know how to do it. What we're looking at is actually area. Listen, area under a curve, which means it's bound by the curve and the x-axis with a domain specified. Could be that bit, could be the whole bit, could be here, could be anywhere. All right. So we're going to look at estimating under a curve using a Riemann sum. So this is the introduction to the fundamentals of calculus, because eventually we're going to look at definite calculus. All right. So now you need to understand the different types of Riemann sums: left, right, middle, lower, and upper. All right. Approximate the area under a curve using an average of the Riemann sums. Compare the method of Riemann sums to inscribe and circumscribe rectangles, and finally generalize the area under the curve of width n. All right. Let's start. Now, if you have got these two functions here, y equals to x and y equals to x plus 4. Can you determine the area under the curve bound by the x-axis over the interval of 0 and 2? Pretty straightforward. This one, you don't even have to approximate. You can actually count.
7, 8,
Or actually use triangles. Right? You can use the triangles. You know the exact measurements here, you know the exact measurements here. Here, you can use a trapezium. Exact measurement here, exact measurement here, exact measurement there. You could work it out, right? So you know one is 4 units square, not just 4 units, sorry, time incorrectly, and 10 units square. All right? So one thing that you really need to know, when we say area under the curve, we mean the area bound by the curve and the x-axis between the given interval. So it's just above x-axis, and that curve plus the interval given, Could be here, could be here, could be anywhere. All right? Now, area is always positive. So there will be a situation where you may have an area here and area here, and you found a negative area and a positive area. But you've got to make sure that you convert the area here into positive. All right? I'll show you that a little bit later, not yet. But just remember, area is always positive. Now, what about a non-linear function? If you've got y equals to x squared, how are you going to find the area of a area under the curve between 0 and 1?
Circumscribe.
Yeah, you can do that, or you can do inscribe, or you can actually
Count the squares.
calculus. But now that's one thing I don't like counting the squares, so forget about counting the squares.
Count it.
It's all right. I don't know why I'm even bothered with that. So we can approximate area by dividing the area into thin rectangular strips. The rectangular strips can be created in three different ways. So most books will show you circumscribed and inscribed rectangles. I'm going to take it further. Left and right rectangles and centered rectangles. All right. By the way, this lesson, it's I have to acknowledge Miss I for helping me to get all the diagrams right and get all most of the contents correct. All right. Now here, you need to. I'm giving you the definition of the Riemann sum. All right. A Riemann sum is a numerical method of approximating the area under a curve over an interval a and b by partitioning the area into finite number of rectangles
I'll put that on the board tomorrow.
typically of equal width n, and summing them together to calculate the area. So if you look at my diagram on the whiteboard,
Negative 1.
so you could, let's say if you want the area between here and here, let's say that's 1, let's say. So what you're trying to do is partition it into different sort of square. All right? Could be like this. Something like this. And, oops, sorry, I need a different color. So you've got, actually it's rectangle rather than square. You've got something like this. You could work on. And remember, the width is of is equal width. So you can see that in here, what I've done is I've got everything equal width, and I've got different rectangles. All right. Now, let's have a look at what to do next. Here, the first thing that you need to know is circumscribe and inscribe rectangular strip. So I've got it for you in your booklet. Circumscribe. The rectangular strips on the curve is to create a rectangle around the curve. So it's always above the curve. All right? So we use this to estimate the area under the curve. Right? So you've got an extra area above. You can use your basic area formula, width times length, to find the area of this strip, this strip, this strip, this strip, this one, this one, this one, this one, and add together. Now, using circumscribe method, you can see that you've got extra, correct?
Yep.
There are lots of extra out there, so we are actually overestimating the area. So this is actually overestimating the area. What we're doing is we're going to use circumscribe and inscribe to actually estimate that. Now, when you have inscribe, so it's actually under or within the curve. You can see that here it's touching the curve, that's touching the curve, touching the curve, touching the curve, touching the curve. So one of the rectangle or one of the strip, the corner will touch the curve. The corner will touch the curve. Since you know the function of the curve, you then know the height, correct? Yeah? You know it's at that point. At this point, at that point, at that point, yeah? Got it? Here, we make sure that the delta x is always the same. Make life a little bit easier, it's always the same. And because it's under the curve, this one is within the curve, you can see that those areas are not counted.
Yeah.
So why we use circumscribe and inscribe is we find overestimate and underestimate, then we take the mean of the two, or the average of the two, to find, to approximate, to estimate the area of the curve. All right? Now, let's think about this. How are we going to do this? Here, I've given you the idea of actually using a rectangle of width 0.25. All right?
It's kind of cold.
And you've got on your handout I've marked very clearly from 0 to 0.25, 0 to 0.5, and 0.75. All right? Now, just follow me slowly. Let's do it together. So here would be 0. This is 0.25. 0.75, 0.5,
Yeah, but you can't approximate. You can't like.
and 0.75. Correct? So we are looking between 0 and 1. This range here. That's the interval, the domain that we are looking at. So you know that it's this area we want. Correct? So I'm going to start off with circumscribe.
Or intercept.
I draw a rectangle from the base onwards until here you can see that one of the point touches the curve. Alright? So this is your first rectangle. Draw the second one. I extend that up. Circumscribe, I want to be over. So this line to 0.5, you know that's 0.5. This is the other line, the other point. All right? And then one more, this point here. And finally, the last point is when x is equal to 1. So now you've got 4 distinct points, correct? And you've got 4 rectangles. And each rectangle, the width, delta x is 0.25. Yeah? Agree? So this point here is f 0.25. Yeah, got it? Agree? Do you agree with me? And this point here is f 0.5, and this point here is f of 0.75. All right? Now, to make life a little bit easier for myself and for all of you, I'm going to use the larger strip. So the area here, just this strip only, will be 0.75 times the height. The height at this point is f1, correct? Yeah. Agree? Do you all agree with me?
It's not 0.25.
No, I'm just using the larger strip. 0.75, 0.25, that's correct, sorry. And that's f1, correct?
Yep.
Yeah? Got it? So we now know this bit here would be 0.25 times f of 0.75 because the height is at 0.75. Here, the height is at 0.5, so it's 0.25 times f of 0.5. And this bit, the smallest bit is 0.25 times f of 0.25.
Yeah.
Agree? Now, I'll write it out. This is overestimating the area. So writing it out carefully, you can do it in a table if you like, you can do it like this if you like. All right? 0.25, f of 0.25, and so on and so forth. Now, if I work with decimal, I'm going to go crazy in this case. Correct? Because you want to find the square of 0.25, square of 0.5, square of 0.75. How about if I work in fraction? Does it make life a little bit easier? So for example, 1 over 4, square of 1 over 4 will be 1 over 16. 1 over 4, square of 1 over 2 is 1 over 4, square of that is 9 over 16. So it just occasionally makes life a little bit easier if you use a fraction. And then you can work that out. And of course, eventually, if you want, work it out as a decimal unit square. So this is how you use circumscribe. What you do is you start off with the defined point. You know where the defined point is. Draw it up. As soon as that touches the curve, draw a horizontal line across and down. You got a rectangle. Then go to the next interval, draw up. You know that you've got this defined point, and do your rectangle. Same here, up, down, and draw a rectangle, and so on and so forth. So you must be able to do this, understand what circumscribe means. You're overestimating. You've got all this extra space, all this extra area. Okay? Yep. Everyone agree with me?
Yep.
Yeah? Think about this rectangle. You are changing the curve into different sort of rectangle. Rectangle that is with a little bit more above the curve. Alright? If you're happy, I'm going to clear this whiteboard. I'm going to move on to the next one. Alright? Let's go. Now the next bit. Here, I want to use inscribe, which means I'm going to think about drawing from inside within. So if I start, I could think about from here. So I've already touched this point. I'm stretching it across. So you can see that I'm within. And this rectangle is actually a straight line. Right? I see. So this, I've started from here. You can see that there's a straight line because I want it to be under the curve. So all the way again, 4 strips, 0.25. Here. That will be 0 here, 0.25, 0.5, and 0.75. So again, you know the strip that you wanted. So you are going to start from here. It's going to be under. Right? Here then, you know that from here to here going up, this is the point. And then go up to there, that's another point. and then go all the way up to here. That's another point to 1. All right? So you know that the area under the curve you want is this. You can see that there are a lot of empty spaces. You are really underestimating. You've got things like here, that's not counted, here that's not counted, here that's not counted, here that's not counted. All right? So again, using the larger strip. The larger strip to illustrate my what I want to teach you. Here, this will be 0.25, the area, times f of this point. From this point up there is f of 0.75, not 7.5, 0.75. Correct? Yeah? Got it? Yeah. So you can see this is 0.25, each little one, 0.25, 0.25, 0.25, 0.25. So you must go all the way up, follow this line up until it touches the curve. So because when it touches the curve, you know that the function, this is f 0.75. This will be f 0.5, and this is f 0.25. Yeah? So must, in situation like this, you probably need a ruler to draw it. And in that case, I've drawn it again. You are actually underestimating the area. So I'm going to write it straight out, just 0.25 times f0, because there's that point here, f0, f0.25, f0.5, f0.75. Again, I'm going to use a fraction. Now you can see that both of them are quite different because one is overestimating, one is underestimating. So in order to do it properly, to estimate, not do it properly, to estimate the area under the curve, what you do is you get the average for the first one and the second one, and then you work out the area, estimate the area under the curve.
Hit it with 2 units.
What did he give for the area for the first one?
Important thing for you to know is how do you find the area? You can start from here,
22
or you
over
can start from
32.
here, doesn't matter. If you want to start from 1, that's fine, work backwards, go all the way up. Once you found the interval, draw all the way up until it touches
Why'd you
the
plus the 32?
curve. And then that's a rectangle.
So you know your
Keep
fraction
working
is-
backwards. You can work backwards or
15
work
over
forwards, it
32.
doesn't really matter.
Plus 7 over
You have
32.
to use like the
That was the last one.
equal sign.
Nah, don't worry about it.
But it's 69 over 64.
It's alright. This one is exact,
You times 1 over
and this is
times
exact
1 over
actually.
4 times
If you
64.
calculate out, it's exact. That's 5 decimal places, that's it.
No,
I think
it's
you're
not the
wrong.
actual area.
No, we stated that's underestimating the area already, so that's fine. We're looking at just
22 over 30.
the area of the
So
rectangle.
in the area, in the question, in the answer, we have to write underestimate.
Yeah. I
That's
mean,
for this one.
when you're giving, when you're
15 over
looking
32.
at the answer, whatever
Plus
question, you
what
will
we got for
know
this one,
exactly
7 and 32.
whether it's underestimate or
So we're
overestimate.
22 over 32.
All right. So from there,
How'd you get 50?
what we need to know
What
is
was on the boards?
calculating the area. So if you were to calculate the average or the mean of the overestimate and the
Can I use a calculator,
underestimate,
please?
we should be able to obtain
Too
a
late.
fairly close approximation to the actual area under the curve. So the approximate area is overestimate plus underestimate divided by 2.
3.
So once you know how to overestimate, you will know how to underestimate. And it's 0.34375 units square. Alright? Now the next bit is, I would like all of you to spend the next 5 minutes just to practice. The practice question is this one over here. The practice question will I will use the same practice question for the three approaches so that we can compare the answer. All right. Now, one of the graph is overestimate. One of the graph is for you to underestimate. All right. So practice question 1. Here. Oh, sorry. Before we do practice question, I've got a focus question which I forgot. Can we actually approximate the area better? How? Make the gap or make the strip a little bit smaller. So this is actually from Sadler. What he did was to make everything 0.1. So you got smaller square, smaller strip, and the actual approximate area is 0.335. Compared to what we have, 0.34375. Close enough what we have, but this is a better estimate. The smaller it goes, the better the estimate is. So I'm not going to leave this, I'm just going to make you aware of this, that's all. You change it to 10, you could change it to 0.05. If you change it to 0.05, you can see that the extra spaces will be smaller. Same with this, the extra spaces will be smaller. Therefore, that's a better estimation. The more strips you have, the better you will estimate the area under the curve. Let's try this. Now this time, I didn't even give you the equation, but I've given you fx. All right, x and f of x. You should know how you use circumscribe and inscribe rectangular strips of width 1 unit. See, 1 unit making life easier. You've got 1, you can draw all the way up. Make sure that you know what 1 unit is, what the width is. So my suggestion is, if you're not sure, you can always draw a dotted line up first. So for example, you could do something like this. Just perhaps a dotted line. This is when x equals to 1. So you can see that if I want to circumscribe at this point here, I will draw a line. All right? That is a rectangle. And at this point here, from 1 to 2, this is my rectangle. Yeah? So I've got that. That is my circumscribe. Yep.
The roof is leaking.
Alright, let me. I'm going to report that. I can't do anything much. I'll turn that off first.
Yeah. Alright.
Is it the roof or the aircon?
I don't know, but look at Ruben's table, it's covered in water. I reckon it's the aircon, though.
Yeah.
The aircon is
It's the aircon. I will let them know.
So how many marks will this be in a test?
This one, 0 to 8, and
0 to 8.
you are asked to use the strip with width 1, so there will be 8 bars.
8 marks.
8 bars because of you've given the width. You were given the width, so it's 8 bars. All right. So this is overestimating circumscribe.
So it's 18 question. This is the entire calculating section.
No, it cannot be the entire count assume section. All right. This is only one small part of it.
So if you have to inscribe and circumscribe and then approximate, that's more marks than the calculating section. If you say it's 8 marks for each choice.
No, I didn't say it was 8 marks each.
You said
No.
8 bars. Oh, 8 bars. How many
I didn't
marks?
say 8 marks. No way.
How many marks, sir?
It cannot be 8 marks. I don't know.
1, mate.
Maybe
3.
Nah, no idea how many marks.
3 marks.
Maybe. All right. So this is how I would draw it.
9.
Nice. Yeah, that's how I did it.
Yeah.
I'm actually so bad at this.
I was actually a bit annoyed with myself. I did all this very carefully at about 11 o'clock last night.
So I drew it
11:30,
first
I
like
deleted
this.
everything.
Oh no.
Yep.
So you missed one.
I did it like
this
these
morning. I
first.
just redid
At first I did it like
I've got
this.
everything saved,
The
but
left
the
and
Left,
the
right,
right.
left, all sense, right?
so you can
That's
see
what I did
here.
at the start, and I was like, oh.
This one
You missed one box.
is
You missed one box.
F
Because left and
zero,
right is like
correct?
the same.
Match to it.
This one
It's
here
to
is F2.
Ooh, actually.
So this one here is F3.
You're not kidding. Look at that.
This is
Caught, he got
F4. This
I did it
one
like this
is
first.
like
Because you have
over
over
here
and
is
under.
Yeah, but it's to do with the cavity. So.
Yeah.
F6.
All right, you did it right, man.
You did it
This
right.
point
You did
here
it
Other
would
than that,
be
Eh.
F7, and this point here is F7. All right. So you can. What you need to observe is you
like
may not
alternating.
always
What?
use the F
It's like
one of the
alternating.
points. So this point is not used, but
The average
looking
of
at
both
this,
is that,
Whoa.
you have this area here
Are these not the same?
is 1 times F2, correct? And this area here
They just copied and pasted
is
it.
1 times
They're both
F3.
left.
oh,
Yeah?
You made it left.
Do you
and
agree
right,
with me?
Yes.
So this is what, if you do it correctly, you don't even have to calculate F1, F2 or whatever. You can actually just get it from the table. The table itself has given you the Y value. So the Y value has been given to you on this table. So you know, therefore, F0, that is actually 11. Or, I mean, in this graph, you can actually read straight away. Correct?
It's about concavity.
You can read from the graph what that point would be. That's 5. That point would be 7. That point would be 10.
7.
So if you work it out, this is the
So how's that 7?
sorry,
How's that 7?
F7,
No, F.
F4
Oh.
is 10. Sorry,
No,
not 7.
F3.
But this is F3, which is 7.
So
9.
that's
Where's 7?
That's
Sorry,
9.
that's 9. That's 9.
Not 9.
9. Yeah.
That's where
Looks
I
like
put
8.5.
9. I did half. It is 8.5.
Nice.
What'd you put?
This
I mean,
is
I
this is
just
my
got the
drawing, but
tables.
you have to use the table. All
Yeah,
right,
just
the
table.
table is given to you. Use
So
the
what'd you
table.
write?
Use the
Yeah, we're at
table.
8 or something.
Yeah, use the table. I mean, it's just my drawing. It should
Yeah, I
be
did 8.
F3, which is 8.
I did do 8s as well.
All right. So
Some
work it
bad
out. This is
left.
62 units square.
Wrote down
Can
like
you
how he wrote
try
the website to
inscribe,
look.
please?
Took a picture
Now
of
that
it.
you've done circumscribe, I've shown
Go
you.
to that.
Can
It
you
made the
try
website
inscribe,
code.
please?
Like,
I
he
just want to
wrote
try
how
to
he
get
wanted
through
it to
the
look
3
like.
methods today.
I'll check it.
Can you try inscribe,
That's insane.
Yeah, no, you can ask like, do a horse.
which is underestimating?
You could just ask it like, oh, do this capture for me. You could. Oh, yeah, actually,
Oh, the capture. Yeah.
capture thing.
Yeah,
If
yeah,
wanna
you probably
bot-
could.
Bot shit, yeah.
That's what captures are.
Yeah, you probably could do it.
Nah, I don't.
I reckon you probably could.
No, because you capture reaching movements.
Yeah, the new
I
ones
will
do, yeah. But like the
message the,
shitty websites.
Run this.
No, like the captures which are like find the bicycles.
Yeah,
that's
that's-
only old books.
They could probably do that.
The new ones tracking movement and searching past the searches receive.
Do that.
Yeah, it's
do
fucked.
that.
It's hard.
If it automatically goes to the bottom.
That's insane, bro. How much does it cost? I actually try buy it. Like,
Do you want to buy ChatGPT?
well, if it's like if you can buy like $5 worth of tokens, then sure. But like, you
No,
have to-
it's like a monthly thing, I think.
Oh, okay.
But I guess if enough people like make an account, you all pay $4 each.
Oh, March 9th. How do you get? How do you get?
ChatGPT, you have to go on OpenAI. You go OpenAI, you just get the premium,
No, but
and
it's
that's
like-
ChatGPT. So
It's blocked. Edge.
Alright.
Because I use Bing Chat. Because of Bing Chat. Because you can ask anything. It's like ChatGPT and it searches for it.
Now, the way I did it, again, I drew it in such a way that the corner of the rectangle just touches the rectangle, just touches
It
the
actually gets from
curve.
websites and then
Alright?
it uses GPT-3.
Does that
It's a
use
lot
to be
easier to use pen and pencil rather than the laptop to do it. But that gives you the idea what I did. Alright? So here, at this point here, I drew a line
heard it
out
was
when it
like
touches the curve. That is
ChatGPT
my
was
inscribe
16 million.
rectangle. Here, from here, this is this point I use.
And
Up here,
ChatGPT
that
4 is
point, this point, that
24
point,
billion
so
or
forth,
something.
so on and so forth.
I don't know what it meant, but like, it was like
Alright, so
It's like much
I
better.
worked this out to be about 38
Yeah, so
units,
this is sources.
which should be 38 units. And of course, the approximate area is 50 units. Alright? So let's write it down. The inscribe and inscribe and circumscribe. That is 50 units square. Alright? Now, let's have a look next bit. This time is left
It's
and right
unblocked as well.
rectangular strip.
Yeah, because it can't block Microsoft.
So what is it?
It's
Microsoft
actually
Edge.
basically
Gonna have
the
to go
same,
with
but
You've got to go on the
now
wait list for
you
permission.
are looking at
that.
just the left
How
corner.
is that?
So this
Yeah,
one,
one
just
minute.
now, with the inscribe and circumscribe, it could be left or right corner. But in this case, left, which means you're just looking at the left corner of the rectangle, that's all. Alright? So you can see that this bit here is this height
This
times
is like the best.
delta x,
This
which is the
best.
same height,
You can just
same
ask
same width.
against
Alright?
sources.
So this area is just this bit, let's say
What is it?
I don't know what it is. Let's say y1 times delta x, and then y2 times delta x, and so forth. So here, the left bound is always used as the height of each rectangular strip. Whereas right, you are looking at this point here. The right bound is always the height. So the difference between left and right, again, in this case, what happened is you don't know whether it's overestimating or underestimating. It could be some will overestimate, some will underestimate. It depends on what the curve looks like. In this case, you're probably underestimating a bit, whereas right, you're overestimating. So you can't tell. Again, to get the area under the curve, you take left and right, and then you do the average. You take the mean, all right? So you have to think about which point you want to use, left bound and right bound, all right? So here, if, for this example, I'm going to use rectangle of width 0.8 units to approximate the area under the curve of that, all right? So here, left bound, left rectangle, so I need to look at this point, this point, this point, this point, and this point, right? You know that this is, delta x is 0.8. 0.8. You usually use the same width. You shouldn't be changing width. So here you know that this is f of -1. This is f of this minus 0.2, f of 0.6, and so on and so forth. Yeah? Do you agree with what I'm doing there? And once you know that, with your calculator, you can sub the information in. All right? Now, one thing that you can do is use your calculator, define the function. Use your define, fx equals to whatever, and then you can work out f1, f2, f3, and so on and so forth. Do you know how to use your calculator to do that?
No.
Yes, no. All right. I will show you in a few minutes. Let's get through this first. So if I want fx equals to x cubed over 8 minus x plus 2. I'll show you how to use the calculator a little bit later. Let's get this out of the way first. So you know that using this, the left bound is 6.86 units square. All right. Now you can see that 0.8 I've taken out because I know the width of the rectangular strip are always the same. The next bit, what I want is I want to write down. So I really need to extend this at that end all the way up. All right? See, I extend all the way up and work backwards. Or you can, instead of from here, you work from here to where the delta x is, which is 0.8, and work up this point. And then you can see that this is your rectangle. And here, this will be f of minus 0.2, f of 0.6, and so on and so forth. And of course, again, if you do that, this is how you work out the right sum. And then work out the approximate area is 6.46 plus 6.86. So it's about 6.66 unit square. Now, what I would like you to do, because we're running short of time, the next bit is, this is the approximate area. What I would like you to do is, with the practice question, this half do right, this half do left, please. Right and left. And in the middle of this line, it's up to you, whether you want to do left or right.
Right? So,
This right? Sorry? Yeah. Right and left, yes. Yeah.
Oh, yep. Wait, what are we doing?
Yes, definitely. Let me finish first, then I'll definitely put it on straight away. Once I've done that.
Axel, you do it right.
So here,
So how do you do it from?
So you go to the left side and then you go
you must be able to do the draw the rectangle,
from the
please.
right side.
Left or right?
Oh.
Oh well, doesn't matter. I mean, really in the exam, you should use a ruler, but I'm not going to worry about it now. You should be using a ruler.
Fair enough.
Yes, sir. Right.
Yeah, that's what I mean. So you do the right one and you go
Right
right
corner, you go right.
Yeah.
You go left, you go right. I'll do left as well.
This is actually insane. I think.
So you need to know what left rectangles, how to do left rectangles, and how to do right rectangles.
Very difficult stuff.
Whether the height is from the left or whether the height is from the right. This is a practice. I mean, these are all approximate. The answer will be very different, I would say. But they are close enough. Who's not the left rectangle? Yeah, what did you get?
Oh, I didn't calculate it yet. So
That's fine. Is this the shape of the left rectangle?
yeah.
Yeah, buddy.
Agree?
Yeah.
Yeah.
It is a bit time consuming because you're going to really start, draw all the way up and then down. But the thing is, the good thing is I've already given you all the points. So if I work that out, left rectangle, I've got 53 units. So this is F0, this is F1, F2, F3, and you can see that I'm practically using everything except F8, right? So, with your right rectangle, I've already given you the,
Oh, so
again, approximate area is 50 units, so it's pretty close. Not too much different. I thought there was a lot of difference. All right, 50 units square. All right, you can see that how I drew right where this point touches the curve, and I draw it up, touch, and up and touch. Now, the last one, you don't have to have a two-step process. The last one, you're drawing the rectangle strip right at the middle of that point. So this point will show you where the middle, you're just using this point, this middle point, and this middle point, right? So here, if you recall, if this is -1, this is minus 0.2. This point here is the midpoint, which is minus 0.6. Correct? Yeah? So you're using the midpoint to estimate. Again, you can see that these two triangles will be about the same area, so it sort of cancel out. This is not a little bit overestimate, a little bit underestimate. That about the same, but here you definitely are only estimating. You are not finding the exact value of the area under the curve. So with the center rectangular strips, it creates using the midpoint between the left and right bounds of each rectangular strip. Alright? So you only need to do it once because you are estimating based on the midpoint. You can see that the plus or minus, the extra and the deficit is about the same area. So here, if I use y equals x squared, again, what I did is I drew that, and realizing that I am splitting that into, instead of 0.25 and 0 and 5, this is 0.125, and so on and so forth, correct? Now, I don't want to work with decimal. This will be 1/8. This will be 3/8, and so on and so forth. Yeah? So if I split into 4, I got 1/8, 3/8, 5/8, and 7/8.
My boy's
Right.
getting reps.
And then you can work out the square up to this point. F of 1/8, F of 3/8, F of 5/8, and F of 7/8. Use your fraction. Makes life just that bit easier in this case.
He dances.
What even?
Alright?
550.
So if you work it out,
20 hours.
it should be about 0.3281
Yeah.
328125 units square. Or 21/60.
She does it throughout.
But you have extensions as well.
Alright, finally, the last one, I would like you to do the practice. Use this. Use the centered rectangle. Use the centered rectangle, please. Use the centered rectangle. Everyone try that, please. Yep.
Oh, with a 2 unit.
Oh, is it 2 units?
Reconstruction.
Why?
Try it. Everyone got to try it. So, now here, I want width of 2 units. You got to read the question carefully. I want width of 2 units. So, the reason why I'm doing that is because you don't have f of half. So I'm giving you an easy way out with 2 units. So you've got f of 1, f of 3, f of 7, and f of 9. F of 7, 5, and 7. Sorry, not 9. So I'm making life a little bit easier for you. 4 strips only, so that you don't have anything that's in between.
So it's not loading.
Just an example.
What's this? What's this inside of it?
So strictly speaking, you should be using your ruler, alright?
Developer.
Oh, I don't give a fuck about that.
Now once you've done that, you can work the area out. It's 44 units. So you can see with the 3 different methods.
You time some things together. Good job. At least this
These
one,
two,
in this one you only have to do it
They are the
once.
same, but the center is
You don't have to
a little bit
add 2
less.
things together.
So this is the best, I mean not the best, the 3 ways of
Add 2 things
approximating
together and
area
divide by
under a curve. Of course there are other methods like counting the square and also making this. The other way of doing it is looking at something like this. Alright? If you look at this, make it a trapezium. Alright? Make it a trapezium. You could use that method as well, make it a trapezium. So in between there will be a straight line.
Yeah, it is.
Alright? So that's another way of doing it, or counting squares.
Oh, stop cheating.
Counting squares, the other one. You know what the squares are. So there are a few ways of doing it.
No, ChatGPT doesn't really know about doing that.
Alright, very last one. So this is just a generalization giving you the formula. Hey, listen. So delta x is actually the width of the rectangle. So it's summing from 1 to n, whatever fx is. So x1, x2, x3 or whatever is summing. Just to make sure that you know where the points are. So this could be f1, f2, f3, f4 or whatever. Alright, now grab your class pad please. I'm going to show you quickly how to use your class pad.
That's
Alright,
ChatGPT
grab your class pad please.
Nah,
Oh, sir,
If you haven't got a class pad, come and get one from me.
Are we going to do integral? The integral with the...
Not yet, the integral with the what, I'll do it later. I'll do the integral a little bit later. So I'm just going to show you the class pad. So with your class pad, oops, wrong one. With your class pad,
Just trying to get it to work.
alright. If you go to main, alright? So under main, what I want is I want to show you how to do this bit.
Please, bro.
Alright, this one. Alright, so with your class pad, let's actually clear everything first. Clear all. And clear all variables, please. Once you've done that, you go to keyboard. Under math 3, define.
What?
Define, under math 3, define f bracket x equals to, put that equation in, which is x
How do you
cubed.
get it to work?
Normally if I do it, I will actually use a fraction. X cubed
Yeah.
over 8
Yeah, but I see what you're getting at.
minus x plus 2. And click enter. So it's done. It's automatically done. So what you need to do is put this right sum in, which is 0.8 times. So you can just write down f minus 0.2 plus f 0.6 plus f 1.4 plus f 2.2 plus f 3.
This is just not conventional.
Alright? And when you hit execute, you got the answer 6.46. Alright, you can do it that
I
way
would
if
just
you
go
like.
like this.
So you need to define a function
We just go like this.
and
Yeah.
then use a function and put the f in. That's it. So this is what your class pad is. It's pretty useful in that sense. Right, I'm going to stop here.
How do you know that?